In this video, we want to learn another formula of integration. This formula is very fundamental and very useful in integrating functions. If you remember from previous videos, integral of x to the n dx is x to the n plus 1 over n plus 1 plus c. We can use this formula to integrate x to any power, but we know that the power should not be equal to negative 1. If we have x to the negative 1, we cannot use this formula because denominator of this formula becomes 0, and so it's undefined. So this formula works for any power of x, but not negative 1. To complete this formula and we can integrate x with any power, we have to have a formula for x to the negative 1. We know that x to the negative 1 actually means 1 over x. And integral of 1 over x dx is ln of absolute of x plus c. And so now with this formula and the above formula, we can integrate x with any power. This formula covers x with any power, positive, negative, but not negative 1. Now that we have this formula, we can integrate also x to the negative 1. And integral of x to the negative 1 or 1 over x is ln of absolute of x plus c. Maybe you ask yourself why we put absolute around x. Why we need to put this absolute here. Actually, by putting absolute around x, we are extending the ability of this formula. X in this formula can be positive or negative. If we don't put absolute around x in the right side of this equation, then we can use this formula only for positive values of x. But we want to be able to integrate 1 over x for any x, positive or negative. So by putting this absolute around x, we are generalizing this formula. And we can use it for positive values of x or negative values of x. And if you wonder where this formula comes from, if you remember from derivative of ln of x was 1 over x. So integral of 1 over x is ln of x, or more generally ln of absolute of x. So now let's try some examples to get more familiar with this formula. Integral of x plus 2 over x dx. To integrate x to the power 1, we can use power rule as usual. Integral of x to the 1 is x to the 2 over 2 plus, and to integrate 2 over x, we write 2 as the coefficient, copy the coefficient, and we integrate 1 over x. Based on the new formula, integral of 1 over x is ln of absolute of x plus c. So integral of x with power rule is x2 over 2, and to integrate 2 over x, we are using the new formula, and integral of 2 over x is 2 ln of absolute of x plus c. Note that 2 over x is 2 times 1 over x, and the integral of 1 over x is ln of x. So integral of 2 over x is 2 ln of x. Another example, integral of 1 over x minus 1 over x2 minus 2 over x to the 3 dx. We can integrate the first term with this formula, but for integrating other terms, we cannot use this formula. This formula works for only 1 over x. To integrate 1 over x2 or 2 over x to the 3, we have to use power rule. We have to move x to the 2 to the top and x to the 3 to the top, and then we can integrate these expressions. So first, we write the integrand, this expression, in the new form, the form that fits with power rule. So we do not change 1 over x, we write it in the original form, but we are bringing x to the 2 and x to the 3 from bottom to the top. X to the 2 goes to the top, it becomes x to the negative 2, and x to the 3 goes to the top, and it becomes x to the negative 3. Integral of 1 over x, ln of x, minus integral of x to the negative 2 based on power rule is x to the negative 1. We add 1 to the power, it becomes x to the negative 1 over negative 1 minus 2, copy the coefficient, negative 2 for x to the negative 3 plays the role of a coefficient. We copy the coefficient and we integrate x to the negative 3 with power rule. Integral of x to the negative 3 is x to the negative 2 over negative 2 plus c. We add 1 to the power again, x to the negative 2 over negative 2. If we simplify this answer, we have ln of absolute of x, negative here and negative here cancel each other, and so this expression is x to the negative 1, negative 2 from numerator and negative 2 from denominator, they cancel each other, so negative 2 and negative 2 goes away, and x to the negative 2 remains plus c. And if you want, you can rewrite x to the negative 1 and x to the negative 2 in fraction form, 1 over x and 1 over x2. And so this is the answer of this integral. Another example. Integral of x to the 2 minus x plus 1 over x dx. To integrate this expression, we cannot use immediately the integration formulas. First, we have to rewrite this expression in a form that fits to the formulas that we have. To do that, we separate numerator. By separating numerator, I mean we rewrite this expression in the form of x to the 2 over x minus x over x plus 1 over x. We are dividing terms in numerator by denominator. X to the 2 over x minus x over x plus 1 over x. x2 over x is x minus 1, x and x cancel each other, 1 remains, and finally 1 over x. Integral of x to the 1 based on power rule is x to the 2 over 2 minus integral of constant 1 is x. Derivative of x, 1. Integral of 1, x. Integral of 1 over x, based on the new formula that we learned in this video, is ln of absolute of x plus c.